A new study may provide answers to the age-old question, what happens to our brains when we die? The revelatory research suggests that near the time of death, rhythmic brainwave patterns may generate memory recall of important life moments. The study's co-author, neuroscientist Dr. Ajmal Zemmar, says that these findings challenge our understanding of when exactly life ends. And joining us now is the organizer of that study, neurosurgeon and assistant professor at the University of Louisville, Dr. Ajmal Zemmar. Welcome. Thank you so much. Before we even get into the details of what happens, I want you to walk us through a little bit about how it happened, how you were able to get this data, because I thought that part of the story was almost just as fascinating.
Thank you very much for having me. It's been a complete accident. We had a patient who had a so-called subdural hematoma, a bleed between the skull and the brain. So we went to operate. The patient did well for 3 days. The patient developed seizures, and we attached what we call a EEG, an electroencephalogram. During this, the patient had a cardiac arrest and died. That was what led us to the first ever recording of a dying human brain.
We've heard about people before who have faced near-death experiences describe this moment where the important moments in their life flash before their head. Is that what we're talking about? Is that what this is?
We have a case of one, so we got to be very cautious about making big statements. But from what this case of one tells us, we record an activity that is very similar to healthy humans that have undergone experiments and testings, that have done out-of-body experiences, hallucinations, memory flashbacks, all the things that are consistently being described by people who undergo near-death experience. These guys have exhibited these brain waves that exactly the same ones we're measuring when we record the activity of this patient 30 seconds before the heart stops beating and 30 seconds after the heart stops beating. That we found was quite astonishing.
And I understand that you know, the greatest questions about what happens when we die have not all been solved through this research, but it is really so interesting, especially that moment that you said 30 seconds afterwards that you recorded. The heart had stopped beating, the patient was declared dead at that point, but the brain was still functioning, and you could record those brain waves. You've said that it might have implications for our understanding of the timing of death, and that might even have implications for the timing of organ donations. Please explain that a bit more for us.
So I think we have to be at least starting the discussion to say, in a traditional sense, we always think when the heart stops working, when the EKG that shows us the function of the heart having a flat curve, we see this in movies, we grew up with this notion that that is the time when life ends. The recording shows that in our case, 30 seconds longer, we record brain waves that potentially could be either a way of the patient continuing to have near-death experiences and memory flashbacks. It could also just merely be a response that the nerve cells are dying. We can't tell what it is right now. We can just tell there is a 30-second span where the brain shows activity. So it opens a discussion to saying, would it be worthwhile, beside the EKG that shows the heart activity, to compare it to an EEG that shows the brain activity to see which of these really determine the time of death?
Dr. Zemmar, I know that this was accidentally recorded. It's sort of a finding that was stumbled upon, and then you and your team were wise enough to look into that data. You, though, plan to continue it by investigating similar cases in the future. Tell us more about what research lies ahead, what questions you hope to answer, and what else you hope to be able to share with people about that tremendous question, what happens when we die?
We have waited for a long time with the hope that there would be other cases like this, so we didn't have to go out with just one case. It is, from a scientific point of view, very thin ice to make conclusions on one case. So my hope is, through the conversation with you, through the conversation, the unimaginable media coverage that this has had across the globe in the past days, other scientists would come and say they may have a similar case, and we could analyze it together and get further insight to either prove what we have or maybe disprove what we find. What does it get for the future, and what implications does it have? I think there's the implications we already talked about, the time of death. There's the implication of every human being experiences death during life of a loved one. We experience death from ourselves at some point. It's something that in life, it's sad, but it's the nature of life. I think it is just as birth. Death is something that we all are interested about. So the neurobiology, the neurophysiology underlying death is an interesting phenomenon that's completely unexplored almost. It will be interesting and fantastic to know more about it, and I hope I can contribute. And to me personally, I think when we have patients, as a neurosurgeon, we see at times patients that we can't help. They have accidents, they have untreatable brain cancers. It is very difficult in those times to stand by the family, be the bearer of bad news. There's nothing we can do. If this research would allow me to go to the patient and say, your loved one has memories of the most memorable moments in their lives, and if that gives them a little bit of calm to know that they're not in pain, but they're flashing back kind, nice memories, that would be a nice gift that I could give to my patients.
Well, it is so fascinating, and I do hope that we'll be able to talk again when you have more data and more to share with us. Dr. Ajmal Zemmar.
I can't wait.
Thank you.
Thank you very much.